So this is mathematical lecture number 11. This is lecture number 11. In this lecture, we are going to see algebra of statements. As you know, in mathematical logic, we are learning different types of statements. Compound statements, statement pattern. A statement pattern has several statements which are connected with one or more than one connective logics. So now when we come across some statements, we follow that there are certain rules, there are certain laws which are applicable. There are certain rules and laws which are applicable on those statements. So the rules, laws which are applicable, they all can be listed under the heading Algebra of Statements. So we have certain laws which we have to learn under the Algebra of Statements. So today we are going to see Algebra of Statement. Algebra of statements are nothing but different types of laws. Now here I have prepared a table for you. In this table, in the central column, I am giving you the name of the laws, and in these two columns, that is left hand side and the right hand side column, I will give you the examples, that is how those laws are being used. So in the central column, we have laws. It is very important for us to remember these laws. So first, let us learn the name of the laws. So there are few laws which you have already heard of, like the words, the names, you must have heard of somewhere. But then there are certain names which are very new for you. So like this name could be a very new name for you, that is idempotent law, idempotent. Okay. Now what I have done is, in all these laws, the first letter I have highlighted. I have highlighted the first letter, that is for idempotent law, it is I. Now see, the name commutative is already heard. We have already heard about this name. We also know the law, what is commutative law. But then we know the commutativity of addition of two numbers. Like see, when we say commutative law, what do we know? That if two numbers we have A and B, so A plus B is equal to B plus A. So we say that the addition of real number follows the law of commutative. So A plus B is B plus A. A into B is B into A. So we can say that the multiplication of real number follows the law of commutativity. So like this, these are different laws, but here, you know, these laws are to be applied on statements, mathematical statements. So how is that going to happen? I shall tell you in a short while. In a short while, I will tell you that. But before that, we need to remember these names. So idempotent law, the first one, I, idempotent law, I. Then we have commutative law, C. Then we have associative law, A. Then we have distributive law, D. Then we have De Morgan's law, D. So the first five, ICADD, ICADD. It is very important that you learn the code, because with the help of these letters, we can remember the complete name of the law. And then we have next identity law, I. Then you have complement law, C. Absorption law, which is A. And then you have conditional law, C, and biconditional law, B. So let me write B first and then C. Okay. So it becomes rhythmic. ICADD, ICABC, ICABC. So these are the first letter of all these laws. This stands for idempotent law. Then commutative law. What are these laws? That I will tell you in a short while. Then this one is associative law, distributive law, De Morgan's law, identity law, complement law, absorption law, biconditional law, and conditional law. So we are going to see these laws. Okay, now I will tell you the examples of these laws. Okay, now let's go for the laws. See, the first one is idempotent law. So I will give you the example of these laws. So here, see, idempotent law means if I have P or Q, P or I'm sorry, if I have P or P, then it is equivalent to P. If I have P or P, it is equivalent to P. And if I have P and P, P and P, it is, remember, equivalent to P. So this is first law, idempotent law. Idempotent law says that P or P is same as P. P and P is same as P. So if you are wondering that what does this mean, so I will tell you the meaning of this. See, it simply means that if you have P or P, P disjunction P, if you have P disjunction P, then then it is same as having just P. Why? See, I give you an example for this. Suppose I have the truth value of P as true. What is P? P is true. So what will I have when I have P or P? I will have true or true. Now tell me, what is true or true? True or true is true. True or true is true. And what was P? P was true. So if you have P or P, it is as good as only P. It is as good as only P. Now see another example. I give you another example here. Suppose P is false. If I have P as false, so if P is false, see what will be left hand side. The left hand side will be false or false. The left hand side will be false or false. And you know, false or false is nothing but false. Okay. And what was the truth value of P? P was false. P was false. And what are you getting from the left hand side? You are getting false. So if you have the truth value of a statement as true, or you have the truth value of a statement as a false, if you have false or false, it is false. If you have true or true, it is true. So P or P is same as P. So if you see somewhere P or P, it is no need to write P or P, you simply write P. This is idempotent law. Same is true for P and P. Suppose I have the truth value of P as true. If suppose P is true. So when P is true, what is P and P? It is true and true. And what is true and true? It is true. And what was P? P was true. P was true. It means the truth value of P and P, the truth value of P and P is same as the truth value of P. It is same as truth value of P. So no need to write P and P. If you have anywhere P and P, you could simply replace that by P. Similarly, suppose if you have the truth value of P you have is F, false. If the truth value of P is false, so you will have false and false. What is false and false equal to? It is equal to false. False and false is equal to false. And what was the truth value of P? The truth value of P was false. So what you understand? You understand that the truth value of P and P is same as P. So if you have somewhere P and P, you could simply replace that by P. This is known as idempotent law. Idempotent law. So P or P is P. P and P is P. P or P is P. P and P is P. What is important here is that you have both the statements same. Remember, don't write P or Q as P. No, it is P or P. P and P, both the statements are same. That is idempotent law. This is idempotent law. So in short, if you have to understand what is idempotent law, it is a kind of operation when you apply on a particular element with itself, the result is the element itself. I repeat again. What is idempotent law? It is a kind of operation when you are applying on an element with itself, the end result is itself. See, for example, if I say 1 into 1, so what is 1 into 1? 1 into 1 is 1. So this is a kind of idempotent law. Okay, it is a kind of idempotent law because when you are applying the multiplication operation is a kind of idempotent operation for 1. It is a kind of idempotent operation for 1. 1 into 1 is 1. And no matter how many times you multiply 1. So this is a kind of idempotent operation. See, it is also followed for 0. For addition. Addition is an idempotent operation for 0. So 0 plus 0 is 0. See, you are applying an operation on an element with itself. The end result is the element itself. 0 plus 0 is 0. This is idempotent law. So the next now we have is commutative law. In commutative law, see, if I have P or Q, it will be same as Q or P. Okay, so the truth value of, for the truth value of P or Q, this is left hand side, the truth value of P or Q will be same as the truth value of Q or P for any given possible truth values of P and Q. So you know, if suppose P is false and Q is true, suppose P is false, I give you an example for this. Suppose I have P as false and I have Q as true. So the left hand side here will become false or true, false or true. And what is false or true equal to? False or true is equal to true. And the right hand side, which is Q or P, it will become true or false. And what is true or false equal to? That is, true or false is equivalent to true. So see what you notice that the truth value of P or Q is same as truth value of Q or P. So you changing the order does not change the end result. This is known as the law of commutativity. It is commutative law. P or Q is same as Q or P. So you change the order, P or Q. Here P is first, Q is second. And here Q is first and P is second. So P or Q is same as Q or P. Okay, then you have, the next you have is P and Q. Okay, now I read the example on the other side. See here you have P and Q. P and Q is same as Q and P. P and Q is same as Q and P. Then you have associative law. See what is associative law? Associative law is P, P or Q or R. P or Q or R is going to be equivalent to P or Q or R. They are going to be same. They will both be same. That is, the order, the combination of association does not matter. It makes no difference. The combination of association will not affect the end result. See, P or Q or R. So first I take the combination. See, I'm making a bracket for Q or R. Q disjunction R. I'm making a combination of Q or R. Then the end result of these two I will take with P. It is going to be same if I take P or Q or R. If I take P or Q or R, that is, now on the right hand side, I'm first taking the combination of P with Q and then with R. What is important here, the connectives are same. You can check, the connectives are same. This is OR and this is also OR. The connectives are all disjunction. The operation is disjunction. Now, associative law, I will write with conjunction. So it says it would be P and Q and R will be same as P and Q and R. They will have the same end result. So the combination of association, see, this is known as associative law because how you associate the two elements, it is not important. So you associate Q with R, then go with P, or you associate P with Q and then go with R. It does not matter. The reason being the logical connectives are same. See, what is here is here. Then we have distributive law. Distributive law is if you have P or Q and R. See, in distributive law, you have P or Q and R. Inside the bracket, between Q and R, between these two component statements, you have conjunction, but outside the bracket, you have disjunction. So P or Q and R is same as, see, this would be distributed. This P or would be distributed. That is why it is known as distributive law. So when you distribute P or with Q, P or Q, you get P or Q, then you distribute with R. So P or R. And in between you have and. In between what you will have and. So this will be P or Q, P or Q and P or R. P or Q and, see, this and is here. You check this, P, this and is here. On the other side, it will be P and I have Q or R. Okay, it is important that in distributive law, the logical connectives are not same. You check this, inside the bracket you have conjunction and outside you have disjunction. This is conjunction and this is disjunction. So the law of distributive works where the logical connectives are not same. And the law of associative works when the logical connectives are same. You check here. This is major difference in the two. Now same thing is here. See, P and Q or R. What will happen? This P and will be distributed for Q for R, and in between you have and. Sorry, you will have or. In between you will have or. So we'll see here P and Q or P and R. This is distributive law. After this, we have De Morgan's law. Let's go for De Morgan's law. Very interesting law. The De Morgan's law is nothing but the negation of disjunction and negation of conjunction. So see, if I have negation of P or Q, if I have negation of P or Q, we know that it will be negation of P and negation of Q. What is negation of P or Q? It is negation of P and negation of Q. You write negation for both and disjunction will be changed into conjunction. Disjunction will be changed to conjunction. I repeat, inside the bracket you have P or Q. You write the negation for both and you change disjunction to conjunction. So negation of P or Q is negation P and negation Q. Then here you have negation of P and Q. You will write this as negation P or negation Q. Negation P or negation Q. So we have completed the first 5 laws. Okay. Just have a check for these 5 laws and write it in your notebook. So next we go for the identity law. Now see, in identity law, if I have, see the example of identity law. If I have P, where P is some statement, if I have P or true, if I have P or true, then remember the truth value will always be true. It is equivalent to true. P or true is equivalent to true. And the another one you have is, if you have P or false, then it is equivalent to P. Now I will explain this to you. Explain these to you. P or true is going to be always true. How that? Let me explain this. Suppose here, okay, let me explain the first one to you. Suppose you have P as, the truth value of P is, suppose, false. So if P is false, see what the left hand side will become. The left hand side will become false. P is false. So false or true. What are you getting? What is false or true? It is same as true. So P is false. P is false, but you are getting the truth value as true. Okay. Next. Now think P is true. Now take P as true. So if P is true, if you take P as true, this time I'm taking P as true. Okay. So if I take P as true, what will the left hand side will become? What will the left hand side become? It will become true or true. True or true. And what is true or true? Again true. So what I want to tell you here is, no matter what P truth value is, irrespective of the truth value of P, it will always have the truth value true if you have P or true. I hope it's clear. P or true is always true. Remember, P or true is always true. And the second one is P or false is always P. Okay, now I will explain the second one to you. The second one. The second one is as follows. Suppose I have the truth value. I'm going for the second one. Okay, so I will write on the. So suppose I have truth value of P as true. Okay, so what will this be? The left hand side will be, it will be true or false. True or false. What is true or false? That is equal to true. Is it not the truth value of P? Yes. So the truth value of P or false will always be the truth value of P. See, when P was true, P or false is true. P or false is true. Okay. Next, let me have the truth value of P as false this time. If P is false, if P is false, so what the left hand side will become? The left hand side will become false or false. And what is false or false? It is false. And it is nothing but the truth value of P. See, P is false. You can check P is false. So if you have P or false, the truth value of P or false will always be the truth value of P. It will always be the truth value of P. Now we come to identity law. Some more examples. See, if I have P and true, then it is always P. And if I have P and false, then it is always false. The example explanation would go exactly the same way. Suppose, let me explain the first one to you. Let me explain the first one to you. What do I have? I have P and true. So P and true will always be P. It only says that the truth value of P and true will be same as the truth value of P. So if I have P as false, if P is false, so what you have false and true, you have false and true. False and true is what? It is false. And false is nothing but P was false. We check this. P was false. So P and true is always true. P and true is always true. P and true is always P. Now let me have P as true. If I have P as true, then what the left hand side will become? The left hand side will become true and true. What is true and true? True and true is true, which is nothing but the truth value of P. See, you got true for the left hand side. And what is this? What is this true? True is the truth value of P. So in short, whatever be the truth value of P, if you have P and true, then the truth value of P and true will be the truth value of P. It will be the truth value of P. This is identity law. Similarly, P and false will always be false. P and false will always be false. After that, we have the next one as complement law. See, complement law is P or negation P, P or negation P is always true. P or negation P is always true. It is always true. The truth value of P or negation P, whatever be the truth value of P, it will always be true. If you have P or negation P, you can check. See, if P is true, then what will happen? Negation P will be false. So you have true or false, which is true. And if P is false, negation P will be true. So you will have false or true, which is once again true. So P or negation P is always true. This is complement law. And on the other side, you will write P and negation P. P and negation P will always be false. What is P and negation P? This will always be false. Okay, after that we have absorption law. The absorption law goes as follows. If you have P or P and Q, if you have P or P and Q, simply write P. As if this whole thing gets absorbed. This whole thing gets absorbed. That's why it is absorption law. This whole thing gets absorbed. You see, what you see is only P. Okay, so P or, if you have P or P and Q, whatever be P and Q truth value, the final truth value will be what P is. Okay, only P will have the say, Q will have no say. P or P and Q, you can check. You can check. Suppose the truth value of P is true. So what will this be? True or true or true and false. Suppose P is true and Q is false. Suppose P is true and Q is false. So you have true or true and false. Correct? That is equal to true or true and false is false. What is true or false? True or false is true. And what was P? P was true. You check, P was true. So the truth value of this whole thing is same as the truth value of P. It is same as the truth value of P. One has to follow that in absorption law. In absorption law, you have the connectives different. Inside the bracket, you have conjunction, and outside you have disjunction. Outside you have disjunction. Okay. Moreover, you see that inside the bracket, out of two statements, one is repeated outside. See, it is P or P and Q. So it will be P. Suppose I had Q or P and Q, then I would have written this as Q. Please mind it. What is outside? What is outside? Everything gets absorbed into that. So Q or P and Q would be only Q. You understand? It would only be Q. I write the example on this side. So this side we would write P and P or Q. See, now I have outside and inside the bracket I have or. And what more? I notice that P is repeated. So this would be P. This would only be P. The truth value of this whole thing, irrespective of what P and Q are. The truth value of left hand side, irrespective of what the truth value of P and Q are, will be same as the truth value of P. It will be same as the truth value of P. And if you had Q and Q or R, then what do you notice? You notice that the connectives are different. Yes. You notice that one of the two statements is repeated outside. Yes. So the answer is Q. The answer would be Q. I hope you followed this. Now we have the conditional law. The conditional law is P implication Q is same as negation P or Q. What is P implication Q same as? It is negation P or Q. And here on both sides you will write the same thing. What you wrote here also you write the same thing. P implication Q is same as negation P or Q. Negation P or Q. Then you have biconditional law. In biconditional law, what you will write? See, biconditional law, you know that P biconditional by implication P double implication Q, P double implication Q is nothing but P implies Q, P implies Q, and Q implies P. What is P double implication Q equivalent to? P double implication Q is equivalent to P implies Q and Q implies P. Okay. Now what I will do is I will apply this on the right hand side. I will apply this on the right hand side, this and this. So see what I will get now. When I apply this, I will write P double implication Q can also be equivalent to, see, I'm just repeating this, but this time for P implies Q, I will write negation P or Q and negation Q or P. These are the 10 laws that we have in our syllabus. I hope you followed it. Watch this again and practice it, copy it, write it 2-3 times so that you will remember it and then you can solve problem on these. So here now we have few questions where we'll be using the laws that we learned. This law, these laws that we have learned here, okay, these laws, all these laws that we have learned, okay, these all laws we are going to use. We are going to use to solve few problems. What kind of problems are those? Check. The question says without using truth table, prove that. Without using, we are not allowed to use the truth table. It says without using truth table, prove the following. So let's begin with the first one where we have to prove that P double implication Q is logically equivalent to this. See, if the construction of truth table was allowed, the thing would have been in a different way. Okay, we have already done such a question where we would prove the logical equivalence of two statement patterns, one on the left hand side, the other on the right hand side, by using the truth table. But here it is not allowed. So see, I will begin with RHS. Okay, let me begin with the RHS here. So what is RHS? RHS here is P and Q or negation P and negation Q. Okay. So next what I will do here is I notice between these two terms, between these two statements, I notice conjunction. And outside the bracket here, outside the bracket, I notice disjunction. So since these two are different logical connectives, I can go for the distributive law. I can go for distributive law. So what am I going to distribute here? See, this whole thing will be distributed. Okay, so it is or and this is and. So you will have this way. So what we will get next is, see, we will get P and Q or negation P. Okay, P and Q or negation P, and it is this and in between, and then I have P and Q or negation Q. Now we will go for another distributive, which is from the right. We will go for distribution from the right this way. Once again, why? Because see, you have or and you have and. They are different. Inside the bracket, outside the bracket, different. So what we will have the next is, see, the next we will have P. See, we are distributing this. Okay, so P or negation P and Q or negation P. So here you will have P or negation P, P or negation P, and this one, and Q or negation P. Okay. Then we have this one, and here also distribution. So P or negation Q P or negation Q and Q or negation Q. Now, as you know, students, okay, let me write the different properties which we have been using. Here, what did I use? This is distributive property, distributive law. This is distributive law. And here also, distributive law. It is also distributive law. Till now, we have been using only distributive law. Now, see what I have. P or negation P. P or negation P is always true. P or negation P is always true. This is complement law. What law is this? P or negation P is always true. P or negation P is always true. Complement law. And here you have Q or negation P in the bracket, then it is, and here you have P or negation Q, and Q or negation Q is always true. This complement law. Here I will write complement law. You can check. This is by complement law. P or negation P is always true. You want to check here. See, P or negation P. Check here. P or negation P is always true. P or negation P is always true. The same law I applied here. P or negation P is always true. Next. Now you have to apply another law. Whereas you see, wherein you have T, what do you have? T and this. You have T and this thing. What thing? T and this thing. T and this thing. Okay. Now you know T and any statement will be same as that statement. T and any statement. If you have T and P, it is same as P. It will have the truth value of P. T and P is P. What is that law? Identity law. Identity law. T and P is P. You can check. You can check here. See, T and P is P. You can check. T and P is always P. So T and this. So you have Q or negation P and P or negation Q. So here, which law did I use? I used identity law. Identity law. This is not yet over. See, the next is, I will use now yellow color. See, now Q or negation P. What is Q or negation P? It is P implies Q. P implies Q is, okay, I can do one thing. Before writing this, let me write commutative law. Students, check this. Q or negation P. Can I write this as negation P or Q? Yes, commutative. If you have or, then you can always you can always change the order. Commutative law. So Q or negation P is same as negation P or Q. And here I will write negation Q or P. What is the law? The law here is commutative law. Commutative. Commutative law. Then you have the next one as, see, negation P or Q is P implies Q. Conditional law. P implies Q is same as negation P or Q. It is same as negation P or Q. You can check. P implies Q is negation P or Q. And this is Q implies P. Q implies P. And what the law here is? The law is conditional law. Conditional law. And now students, when I have P implies Q, conjunction Q implies P, it is P if and only if Q, that is P double implication Q. This is biconditional law, and that is equal to left hand side. That is left hand side, and hence proved. We have proved it. This is left hand side. I write here biconditional law. Biconditional law. This is left hand side. I have proved it. Now we have here another question in which we have to prove the logical equivalence, but remember, we don't have to use the truth table. So this left hand side is logically equivalent to right hand side. Okay, let's go ahead. So I will begin here with left hand side. So the left hand side here is P or Q and P or negation Q. P or negation Q. So I notice here or. I notice or, and here I have and. So what will I do? I will distribute this and over or. Okay? Because inside the bracket, outside the bracket, I have two different connectives. So I will have here P or Q and, you know, how is this going to be? This with P and the whole thing with negation Q, with negation Q. Negation Q is one statement, remember that. So P or Q and P, P or Q and P, or P or Q and P, or P or Q and negation Q. This is distributive property, distributive law. So here I write here distributive law. Okay, again, I notice that here inside the bracket I have disjunction, but outside it is conjunction. Again, it is change. So I will have to apply distributive once again. So I will apply the distributive law. See, so I will have P and P. See, P and P and Q and P. You understand? In between, we will have or. See, these are very simple laws, but you need to be careful while applying them. So P and P, or I'm noticing something here. If you remember, students, this could be here. You know, we can think of applying the absorption law. See, absorption law. How absorption law will work here? See, inside the bracket and outside the bracket, we have two different connectives. Out of the two statements which are inside the bracket, outside I have one of them. See, we got P here, we got P here. So the whole thing will be equal to simply P. It will be simply equal to P. So this whole thing is P. You understand? P or Q and P is same as P. I could have used, see, I could have done it the way I was doing it, but then suddenly I realized that I can use the absorption law. So I went for that. Okay, so this whole thing is simply P. This whole thing is simply P. Or, but here nothing can be done. Here we'll have to use, because this is outside negation Q, not Q. This is negation Q. So we will have to use the distributive property. So this is P and negation Q. P and negation Q. Okay, P and negation Q, or Q and negation Q. Okay, so here two laws that we used were, we used absorption law and distributive law law. Then we have P or, now check, this is P and negation Q, or, now Q and negation Q will always be false. Remember this will always be false. Q and negation Q is always false. This is complement law. What law is this? Complement law. Q and negation Q is always false. I will write here. See, for this I'm writing false. You know, if Q is true, then negation of Q will be false. And if Q is false, then negation of Q will be true. So true and false, false and true is always false. So here you have, you will write, you're using complement law in the third step. Complement law. The next one you have is, now you know that a given statement, if you have, for a given statement, you have disjunction with false, then it is always the given statement. The truth value will be of the given statement. What I'm trying to tell you is P or false. P or false is always P. Is always P. P or false is always P. P and false will always be false. P or false is always P. P or false is always P, right? So here you have this statement or false. So it will be P or P and negation Q. Which law did we use? We used the identity law. Identity law. Now we have once again the distributive. Why distributive? Again we have absorption law. See how absorption law will work, student. See, here we have or, inside we have and. So they are different. They are two different connectives. Further, inside the bracket, out of the two statements, one is repeated. See, we have P and negation Q. Here we have P. So you know it will be the truth value of P. So P or P and negation Q is simply P. Which law? This is absorption law. This is absorption law. Okay, and that is equal to RHS. This is equal to RHS, and that's it. Hence proof. I hope you have all followed it. You can just copy this. See, you need practice for this. You solve few problems on your own. Slowly and slowly you will become good in it. Okay, so here we have the third one. Once again, we have to prove the logical equivalence of left-hand side and right-hand side without using the truth table. So I will begin with left-hand side. So the left-hand side here I have is P and Q, or negation P and Q, or P and negation Q. Okay, P and negation Q. Now see, we have three statements, and here I notice three statements: one, two, three. Now, in between these three statements, the logical connective I have is same. So I'm going to use the property of the law of associative law. What does that mean? Whether I take these two first and then I consider the third one, or I take these two first and consider the third one, it's not going to change my final result. So I will go for these two first. Okay. So let me write these two in a bracket. Okay. So I'm going for these two first, because it's between this I have associative, between these two I have disjunction, and here it is disjunction. Okay. So the law which we are using is, if you remember what the law was, P or Q or R will be same as P or Q or R. Okay, it is this way. It is this way. So what I'm trying to tell you is I can take these two in a bracket. Now, then what I notice something very interesting. See, I will take, I notice that here I have got negation Q. I'm sorry, here I have got conjunction Q. Here also I have conjunction Q. And in between I have disjunction. What do I have in between? In between I have disjunction. Okay, so I'm going to take conjunction Q common. So this is going to be common. So when this is common, see, this is once again distributive property, but it is distributive in reverse. So you will understand it. Don't worry. So see what I will get. I'm going to get now P. See, I will get here P, this P, or negation P. You check this because I'm taking this common. So I will get here P or negation P in a bracket conjunction Q. P or negation P conjunction Q, bracket closed, and P and negation Q. P and negation Q. Okay. Then now see P or negation P. What is P or negation P? What is P or negation P equal to? You know, P or negation P is always true. Okay, this is always true. As I told you that from here, see, this property which I'm using, you know, from here, from this step, this one which I got, how did I get it? How did I get this step? This whole thing, how did I get? It is nothing but distributive property. But only thing is this I used in reverse. How did I use it? I used this in reverse. How? I'll let you know. See, if you had to distribute negation Q, if you had to distribute conjunction Q over disjunction, how would it go? How would that go? Wouldn't it be P and Q Wouldn't it be P and Q, disjunction, negation P and Q? See? So if I could distribute this, what I'm trying to tell you is, if this can be distributed, okay, it can also be taken common. It can also be taken common. You can compare this. I can give you an analogy with what we do in numbers. See, if I have 5 multiplied by x plus y, so if I can distribute this and I can write 5x plus 5y, if I can distribute 5, multiplication of 5 over sum, I can also take 5 common. Yes or no? See, 5 into x, 5 into x. So I can take 5 common. And when I take 5 common, what I get? 5 common, I get x plus y. So it is the same thing. We are doing it here. Distributive property it is. I hope you have followed. Now, next thing is, so here I will write this as distributive property, distributive law. Then I have here P or negation P is true. This is complement law, and Q in one bracket, or this is P and negation Q. So I write here complement law. Complement law. Now I have the next one as, see, P and Q. P and Q is always Q. True and Q will always be Q, because if Q is false, then you will have to write false, true and false, false. And if Q is true, then you will write true. So ultimately, it will be the truth value of this will always be the truth value of Q. Okay, so P and Q is Q. Or here you have P and negation Q. This is identity law. Here I'm using, which law did I use? I used identity law. Then once again, it is distributive law. This is outside, I have disjunction, and inside conjunction. Okay, so I will write here distributive law and see what do I get. I will get Q or P and Q or negation Q. This is again distributive law. So the next step, students, it will be, see, it will be Q. Okay, see, this Q or P can be written as P or Q, and Q or negation Q. Q or negation Q is always true. Q or negation Q is always true. Because if Q is true, negation Q will be false. You will have true or false. And if Q is false, then this is true. You will have false or true. It will always be true. Which law is this here? This law is complement law. Complement law. And we also used commutative law. Commutative law. Then I have here, see, P or Q and true will always be P or Q. P or Q and true. It will be same as the truth value of P or Q. This is identity law. Identity law. And that is equal to RHS, hence true. I suggest you to go through two laws very well, very thoroughly. The one is complement law and the other is identity law. Complement law and identity law are to be studied very, very, very thoroughly. I repeat it once again for you. See, complement law. If you have P and negation P, P and negation P, then it is always false. P and negation P. Why false? Because if P is true, then this will be false. And you know, true and false, false. If P is false, then it is true. False and true is false. So this is complement law. If you have, if you have P or negation P, if you have P or negation P, then this is always true, because one of the statement will be true, irrespective of what the other is. One will always be true. So if P is true, this is false, no matter, because true or false is true. And if P is false, then this one will become true and false or true is true. So P or negation P is always true. P and negation P is always false. This is complement law. And then identity law. In identity law, you have, if you have P or false, then remember it's always P. If you have P or true, then it's always true. P or false, always P. P or true, always true. Because even if P is false, it is false or true, true. If it is true, then true or true, true. It's always true. And this is all identity law. P and, if you have P and true, then it's always P. P and true is always P, because then the truth value of P will have the say. It will have the say. If P is false, then false or false and true is false. So it is C. Whatever P is, that plays a significant role. So P and true is P. If you have P and false, remember it's always false. P and false is always false, because whatever P be, it is and false, so has to be false. These two laws are most important laws. The other laws are something that you will remember somehow, because you have also studied it earlier in under certain other name, but then you have studied it earlier. Now we have question number 4, which is the last question for this lecture. And after that, you can have plenty of practice problems from the textbook that you are using. And see here, we have to prove left hand side equal to right hand side without using the truth table. So I will begin with the LHS. What is LHS here? The LHS is negation of P or negation Q implies P and negation Q. Okay, so here, as you all know, P implies Q is same as, okay, see, we have outside negation. So first I will apply the negation law. What is negation of P implies Q? You know, it is P and not Q. Negation of P implies Q is P and not Q. So what will this become, students? See. So negation of this implies this will be this and not this. Okay. I hope you are following it. So we will have P or negation Q and not P and negation Q. Now what I have, see, this is P or negation Q, and now take this inside. Okay, that is De Morgan's law. So it will become negation P or Q. It will become negation P or Q. Check this, negation P or Q. So I applied. Which law did I apply? Let me check and write it. So I applied here. The first one we applied was negation of. We applied negation of implication. We applied here negation of implication. And the second one, we applied De Morgan's law. See, negation of conjunction. Negation of conjunction is the disjunction of their respective negations, right? So here I have negation, I'm sorry, it is De Morgan's law. De Morgan's law. Now check what we have on right hand side and what are we getting. Oh, great, we got it. We have got the RHS in 2 steps. That is fantastic. See, this is equal to RHS, hence proved. Hence proved. See, so correct law you apply and you solve it within no time. This completes the algebra of statements. If you have any more problem, you can write it in the comment section. I will solve more problems on this. Thank you.